Hey there, and welcome. So, if you've ever built a website that lets people upload their own photos, you know the exact headache I'm talking about. Your users want to upload these beautiful, super high-res pictures straight from their phones, but, well, that can cause some pretty serious problems on the back end.
Right? It's a great question. You've got this awesome photo, you go to upload it, and the site just hangs. Or maybe it just flat out rejects your image. So what's going on? Well, the answer is actually really simple. The file size.
You know, a single photo from any modern smartphone can easily be 12 megabytes, or even bigger. And that is a ton of data for just one picture. Especially when you start multiplying that by thousands of users, it adds up fast. And from there, the problem just snowballs. For the user, it means a super slow, really frustrating upload experience. But for you, the person running the site, it's a total nightmare. You're just burning through expensive server space, you're eating up all your bandwidth, and eventually the server might just throw its hands up and reject the file altogether, leaving everybody frustrated. So yeah, that is the core issue we are diving into today. Let's call it the big photo problem. How in the world do we let users upload these huge, beautiful images without, breaking everything? All right, let's start by looking at the most common way developers try to solve this, and why it's basically just a big gamble. It's this fixed quality approach, and honestly, it tends to fail right when you need it the most. So the standard thinking is pretty simple, right? Just compress every single image that comes in to a fixed quality. Let's say we pick 80%. On the surface, it sounds totally logical, but it has this one massive hidden flaw. And this is where it all falls apart. Let's say you take a really complex photo, one with tons of detail. You compress it to that 80% quality, and the result is still over 2 megabytes, way too big. But then you take a much simpler photo, maybe one with a plain background. That same 80% setting completely crushes it, turning it into a blurry, overcompressed 150 kilobyte mess. So the bottom line is pretty clear. With a fixed quality approach, you have absolutely zero guarantee of what the final file size will be. It's a total shot in the dark, and you're always going to end up with files that are either way too big or just look terrible. Okay, but what if there was a better way, a much smarter method that could guarantee the perfect file size every single time? Well, this is where our hero enters the story: recursive compression. Now, I know it sounds a little technical, but the idea behind it is actually beautiful in its simplicity. Instead of just compressing once and, hoping for the best, this process tries again and again and again, making these tiny little adjustments to the quality until it hits a very specific file size. Exactly. This quote really nails it. The whole goal is to automate this process with a clear purpose. We're basically telling the program, look, I don't care what the final quality setting is, just do whatever it takes to make sure the final file is under 600 kilobytes. So how does this smart try again loop actually work under the hood? Let's break down the logic. It's pretty cool. Okay, so think of it like a really diligent assistant. First, it starts at the absolute best quality possible, 100%. It compresses the image, then it checks the size. Is it bigger than our 600 KB target? If it is, no problem. It just lowers the quality a tiny bit and tries the whole thing again. It keeps repeating this loop until, boom, that file size is finally under our target. Theory is one thing, but let's actually see this thing in action. We're going to take a huge 5 megabyte photo and watch this process work its magic to get it under our 600 kilobyte goal. All right, here we go. Attempt number 1. The system starts at max quality, 1.0. The result? A 1.2 megabyte file. I mean, that's a huge reduction already, but it's still way over our target, so nope, too big. On to attempt 2. The quality gets nudged down just a little to 0.95. Okay, now the file size is 950 kilobytes. We're definitely getting closer, but we're not there yet. Still too big. And now attempt 3. The quality is lowered just a bit more to 0.90. And look at that. 580 kilobytes. We are officially under our 600 kilobyte target. Success. The loop stops right there. It doesn't compress it any more than it absolutely has to. It found the highest possible quality that still met our size rule. Perfect. Oh, and it gets even better. This intelligent approach can also do other cool things, like automatically converting all images to the super efficient WebP format. It can also cap the maximum dimensions, say to 2K resolution, so you're not storing these gigantic 8K photos. And maybe the best part of all of this processing happens right there in the user's browser.
before the file even hits your server.
All of this brings us to the final outcome. What this method really gives you is the perfect balance. It is truly the best of both worlds.
And this just puts the difference in such sharp contrast. On one side, you've got the old way, the gamble, totally unpredictable file sizes and quality that's all over the place. And on the other, you have the recursive method, a guarantee. The file size is always exactly what you want, and the quality is automatically the highest it can possibly be for that size.
So why does all this matter? Well, it means a faster, much smoother experience for your users, because their uploads are suddenly quick. For you, it means huge savings on your server storage and bandwidth bills. And really, at the end of the day, it just means happier users and much, much happier developers. So, to wrap it all up in one sentence, you get the smallest possible file that meets your rules with the highest possible visual quality it can have. It's not a gamble, it's a guarantee, every single time. And that just leaves us with one final thought. This try again until it's right logic is just so incredibly powerful. It makes you wonder, where else in the world of development could a smart recursive loop just like this one be used to solve another complex, unpredictable problem? It's definitely something to think about. Thanks for watching.